So let's go into the topic. First of all, as mentioned, we want to talk about the motivation for automation. There are 2 points I want to figure out from a very long list, but those 2 points I want to show to you. First one is the demographic change. So we have some customers telling us they are not able to run their orders because they do not have enough skilled workers and operators. And this lack of these operators is estimated by 7 million skilled workers in the year 2030. You can see this very clearly on this graph. The population of persons above 65 years is increasing, while the population of 20 to 64 years is decreasing. Although the job beginners with an age below 20, under 20, is decreasing as well. So we have a very strong demographic change. 2 numbers that I want to figure out are the training places. So we had in the year 2021, 63,000 training places and only 24,000 appliance for this. So this gap is a very huge one and shows which direction we go. The producing industry is especially affected by this problem because more and more school leavers aiming for an academic career. That means they do not go to classical trained jobs anymore in this way. But also inside the trained jobs, we have a shift from the technical sector to the more commercial and social sector. For example, for that, the machining mechanic, which has been on the rank top 5 rank in the last years, fall down to position 14 in the most loved jobs. As a summary, the lack of skilled workers is reality and arrived in the economy. And with our automation solutions, we can work against this to stop this and have a solution with running machines with less operators. The second point is the economic pressure. So machine manufacturers from Far East often offer very cheap products, which becoming more and more efficient. On this graph, you can see exports from Europe are decreasing, while imports to Europe from Far East are increasing. So even the local markets, we are facing a very strong competition in the meantime. So we need something to separate us, and this is better technology and also a broader portfolio. So we want to offer automation solutions to fight this economic pressure. In addition, in the middle of Europe, we have very high staff costs. Let's do an example here. If we calculate a machine operator with 33,000 euros per year, we have around about 120,000 euros if you work 3 shifts, including the markups. If we calculate automation solution by around about 250,000 euros, this is amortized by approximately 2 years. So you can see automation also helps us for getting very good solutions on fighting the economic pressure from our customers. In addition, with automation, we can minimize the downtimes. According to a big German health insurance, employees' sick leave was hitting a new record by this year and the last year. So against this, just to show at this point, the technical availability of an KUKA robot with a mean time between failure of 400,000 hours. So I think these figures speak enough for themselves, and that's all for this short summary why we as EMAG want to offer you good and proper automation solutions. So I want to hand over the word back to Johannes, who will introduce to you our machine-related automations.
Yes, thank you, Jan, for that. As you know, our EMAG machines are very well automated. So here you can see a machine out of the VT series. This series is designed for machining shaft parts. You can see the machine has 2 turrets inside. On the top, side, here is the spindle, and we got the tailstock on the bottom of the machine. Left and right side on the machine, we have an automation system. It's a shuttle or maybe a conveyor. The turrets of the machine don't even carry just the tools, so they also carry a gripper for the parts. So the turret leaves the machine in this area, grips the part of the automation, and then unloads the part directly into the spindle of the machine. If the part is finished, then the second turret grips the part and unloads the part to the other side. Our VL series machines, they are designed a little bit different. So here we have a turret with the tools on the bottom, and we have a spindle mounted on up to 3 axes. Also, we have an automation conveyor or shuttle on the left-hand side, and this automation has a pickup station included. So, like you can see here, the spindle with the chuck can leave the working space of the machine and pick up the part directly out of the automation. Then move the part to the turret where the part is getting machined. And after that, the part can unload back to the automation of the machine again. Here you can see a VL3 Duo machine. Duo stands for 2 spindles inside one machine, and each of the spindle has its own shuttle, you can see in here. To interlink these 2 shuttles now, we use our track motion automation system to load the pallets on the shuttles and also do the turnover from the OP10 to the OP20 part. It's also possible to integrate a stacker conveyor. Here, the customer can load a lot of raw parts stacked above each other, and the track motion can feed the raw parts to the machine and also stack the finished parts back to the conveyor. With this track motion system, we are able to interlink a lot of our machines. So the track motion can move through or drive through the backside of the machine. There's an opening, and load each of the machine shuttles. And with this solution, we are able to interlink several machines and generate bigger production lines.
Thank you, Johannes. So far about the machine-related automation. You see our machines do automate themselves by the handling they have inside. But our goal is increasing the autonomy by several solutions, several automation solutions. And this is what we want to introduce to you right now. First, we want to show you our SCS4. SCS stands for Stacker Cell System, and 4 for the 4 internal slots which can be used for the basket handling. As I mentioned, this work cell is built up for basket handling because baskets are everywhere available in the production for carrying parts from one position to the others on trolleys. The principle about this machine, like all our automation solution, we install everything on a basic frame. On this basic frame, we have in addition this gantry system for the internal handling of the baskets which are feeded in here in the front on trolleys on floor level, and then will be destacked and positioned to the back to the rear positions. We have a position for the finished parts, one for the raw parts, and a buffer where we can stack a not completely filled baskets sorry, until they can be placed on the finished parts stack on the very end. To be able to change the trolleys in the front in parallel to the cycle time, we have this workspace separation. So we can close the door from the top side, so the handling can continue operating in the back side, and the operator can change the trolleys in the front. On the housing, there are located 2 transfer positions. As I already mentioned, the SCS4 is for the basket handling, but the workpieces inside have to be handled by a separate handling system like a robot or gantry system. Therefore, the internal gantry places the baskets in the top position where the handling system can take the workpieces in and out. For loading and unloading, we have 2 solutions. The simple one is a manual loading door in the front, which can be replaced by an automatic roller door. Within this roller door, we are also capable for AGVs because this door can open automatically, so we do not need any operator at site. We are prepared for left and hand side connecting of the external handling system, and the energy container is positioned on the back side, also fixed connected with the machine in order for having no rewiring at the customer side. If it's not possible to keep this energy container on the backside because of layout issues, it can be separated, but in the basic functionality, it's connected to the machine. So far about the principle of the SCS4, and Johannes will show you how the SCS4 can be integrated in our projects.
Yes, so thank you, Jan, for the introduction of the SCS4. So here we start. Here you can see an SCS4, which is loaded via a FANUC robot. This robot unloads the parts out of the transfer position and loads the part to the VT200 machine. Also, the finished parts are loaded back to the transfer position 2 of the SCS4. So we have both part situations inside one cell. Also, the stacker handling is done here via an HEV solution. This situation we had at the very end of a big production line. So we had here an VTC200 machine, which did the last operation of the part. After the last operation, the part gets loaded to these 2 measuring machines via a gantry. And also this gantry unloads the finished part to the SCS4 cell. So here we had that situation that all the parts are in one line in the basket. So here it was possible to load it via a gantry. Also, the operator unloads the complete stacked finished parts out of the SCS4 and filled in empty baskets back to the SCS4. Here we have a repacking cell. This cell exists out of 2 SCS4 machines. Each of the machine has 1 KUKA robot. And these 2 machines are interlinked with a big gantry loader. The robot unloads the part out of the transport baskets and load the parts directly to a hardening basket. The gantry stacked these hardening baskets full of parts, and then the parts get transferred to the hardening machine. After the parts are hardened, then they came back to the cell again. The gantry separates the hardening baskets again to the SCS4, and the robot unloads each part back to the transport basket of the SCS4. As a summary for the SCS4, here we have a compact basking stacking cell. The stack change is parallel to the cycle time. We have a high autonomy due to internal buffer slots. and we are very flexible in the loading and unloading strategy. So the SCS4 can handle just raw parts or only finished parts or both of them. And we also have the HEV capability with the automated roller door inside.
Thank you for Johannes, for this summary. We've got the first question from the audience regarding the SCS4. Because we introduced the SCS4 as a basket handling system, and the question is, can the basket stacking cell also be used for workpiece carriers and blisters?
Yes, okay. Thank you for the question. It's a very good question. Yeah, the workpiece carriers are very good handlebar with the gantry loader. At the blisters, blisters are very flexible. So if we have to handle a full blister filled with parts, then the flexibility of the blister is a little bit critical. But please send us your 3D files with the blisters or real blisters so we can check it and we can have a detailed view at the tripper of the SCS4, so we can decide if it's handle or we can handle these blisters or not.
Okay, thank you very much for answering this question regarding the CRC. The SCS4.
You're welcome, yeah.
Sorry for that. CRC is our next topic. So let's continue with this. CRC stands for Compact Robot Cell, and this was in our focus during the design phase. We want to design a work cell with a minimum footprint. And let's go to the concept again. Like the SCS4, we have this base frame where everything is installed on. Different, we have an internal robot here, so we go ahead with two different robots. We have the KUKA and also the FANUC, which are both available for our machines. The loading of the parts takes place in the front of the work cell. So we have this drawer system in the front. Now you can see the drawers in the middle position. It can be moved out manually by the operator for a very comfortable change of the pallets on the drawer. Then it's moved manually back to the middle position, like shown now. And from there, it can be moved automatically inside the workspace of the robot where the part handling can take place. The amount of these drawers can be increased up to 4 layers. Within these 4 layers, you have a much higher autonomy, but also you can use those different layers for preparing different work pieces and different batches for mixed run of the cell. That means if you use and work with smaller batches, you have a higher flexibility within the higher amount of layers. Same like the SCS4, we can separate the workspace of the operator from the workspace of the robot by this door. Brings us to the situation then that the operator can change the finished pallets on the front side without stopping the robot. This is interesting if you're facing very short cycle times, which you often have with small parts. And this machine is made for small parts, so this is a very, very good option to increase the efficiency of this work cell. The housing is designed in that way that we have one access door on the front side where we can exchange the pallets very easily, and the second door on the back side for entering the workspace of the robot for teaching and maintenance work. This system can be also added by a separate drawer on the side for ejecting not okay and SPC parts. And now about the control. We have this cabinet where we install all the control components inside. Also the robot controller is inside here, and also our 15-inch panel for operating. We have all the valves and stuff like this on this fluid plate on the back side, but accessibility accessible from the outside. So in case of maintenance, this is very comfortable as well. Regarding to the layout and regarding to the machines we want to load with our CRC, we are able to switch the cabinet like here, positioned on the left side, also to the right side. So we can arrange it according to the place situation at our customers. So far in the first run about the principle again, and Johannes will show you how to use it in projects.
Yes, so thank you. Here you can see we are having a CRC just beside a K160 gear hobbing machine. The machine has its working space in here and an automation space in here. These two spaces are interlinked via an internal gantry loader, and our CRC enters the space of the automation area. Here you can see a video of this situation. So the robot grabs the raw part and loads it directly to the gripper of the internal gantry. After the robot grabs the finished part and then load it back to the drawer. In this situation, we had very small parts, therefore we got a big amount of parts inside the CRC, and we reached a very high autonomy. In this layout, we have an CRC beside an VL3 duo machine. The two spindles machine the OP10 and the OP20 of the part, and the two shuttles transport the part outside the machine into the area of the robot of the CRC. So the CRC unloads the raw part out of the drawer and loads it to the shuttles of the machine, make the turnover from OP10 to OP20 shuttle, and then afterwards unload the finished part back to the drawer of the CRC. In this layout, we can see a CRC just beside an VL4, and here the robot loads directly the part into the spindle of the machine via the automation space. Here we also have a video. So here the robot grabs the raw part and waits in the automation space of the machine. The spindle moves outside the working area, and the robot changed the part from the finished part to the raw part. And we reached here a changing time less than 4 seconds. So if the robot loads the last finished part back to the pallet, then you can see that the drawers can change automatically to the next layer. And now the robot has the opportunity to see the next raw part layer. Again, as a summary for the CRC, we have a very compact robot cell for workpiece carriers on a minimal footprint, convenient loading due to full extension runners, cycle time parallel pallet change, and flexible workpiece handling via an integrated industrial robot. And optional, it's possible to mix the operations for small batch sizes. So we have the opportunity to have on each pallet a different part, if that's needed for our customers.
Thank you, Johannes, for showing that. After the CRC, we want to introduce to you the MRC. C stands for compact, M stands for modular. So the focus during the design phase of our MRC was the flexibility. Here you can see this work cell is even bigger than the CRC, but it gives us more possibilities of using than the CRC has. Nevertheless, from the design, we took care about that we can transport it at once on the truck. For example, the width of the complete machine is at 2.70 meters, so we can also transport it without any deinstallation. As you know, EMAG has a lot of different technologies to provide. We do turning, we do grinding, we do gear cutting, and also laser operating. So we have a lot of different technologies. And within this work cell, this was also one big goal of the EMAGLLC. We want to interlink those different technologies from single operations to one complete manufacturing process. Let's go a little bit more detailed to the design of the work cell. Same like the others, we have one basic frame created out of a base plate where the robot can be installed, and all of the cableways for the robot are prepared. The energy container on the back side and the access door on the back side are available, and in the front side we are prepared for different feeding solutions. According to layout issues and the space situation at site, we are able to move the energy container and the access door to the left and right-hand side and flip the situation also on the back side. As already mentioned, the workpiece handling takes place by an industrial robot as well, and we go ahead with Fanuc and KUKA. You can see we have much bigger machines in here, like the CRC. This is two reasons. Because first one is we are facing bigger parts inside the MRC, so we had realized a project where we have handled raw parts with 50 kilos. And the second point is that we need a bigger working area, bigger work range of the robot for being able to handle bigger pallets and containers as well. The housing of the MRC is also modular, so we can close it where no machine is available, and we can open it easily by separating several panels for being connected and interlinking of the machines. Also, these panels are designed in this way that the MRC can be located directly beside the machine without any influence of the accessibility of the maintenance door of the machines. So this has also been on our focus. Regarding the loading, we have different configurations. One is going ahead with two big slots with 1,100 millimeters. In Europe, we know the Euro pallet with 800 millimeters, but worldwide we also are facing much bigger containers. Also, if we go ahead with the Euro pallets feeded in by top-loading AGVs, we need more space than the Euro pallet itself. So this solution is also suitable for AGV loading. In the next step, we have four slots, which is very comfortable if you have basket handlings, because every single bay provides you a higher autonomy. With this four bays, you can feed in, for example, 3 raw part baskets, which can be shifted internally, so you have a very high autonomy. The most flexible solution is the mix of 2 bays with 400 millimeters and one smaller bay with a solution of 400 millimeters. For example, you can do a mixed run. You can have raw parts in the right-hand side, maybe on a pallet or a mesh box. You can feed in baskets on the very left side, and you can stack the finished part to the baskets on the middle position. So within this, you have a very flexible solution and can also run with different parts and different containers for raw and finished parts. The HMI is located in the front side, same like the CRC. We have a 15-inch panel, which gives us the possibility also to handle camera operations easily on this panel. It's big enough for stuff like that. Let's take a more detailed look on the single base on the front. The very right-hand side position, left-hand side position now is closed with a manual door. For example, as mentioned before, you can feed in here empty baskets. We also use this for very heavy not okay parts, which can be placed directly on a trolley and feed out on this way that the operator do not have to carry it anymore. The other functionality, another option, is placing an AutoK drawer here or an SPC drawer for ejecting the AutoK part and feeding in SPC parts if you do the measuring outside the work cell. The front doors can be created manually in this way. So you have the loading doors on the backside, on the downside, which are prepared for container height of 800 millimeters. 800 is a standard measurement for our European mesh boxes. But you can also open the complete front with the upper doors in case of maintenance. Then you have very good accessibility to the work cell and also to the connected machines. As already mentioned, the flexibility was in our focus for the design. So we decided to take not the minimum footprint. We reserved some 1 square meter internally for function extension. That means we want to give the work cell, which is often waiting for the machines because of the cycle time, the possibility to add secondary processes to the machine. In this nice animation, you can see different ideas how this space can be used. For example, just a buffer like shown in the beginning, or a camera detection, or like shown here, a topic which is getting more and more important, the laser marking or marking of parts anyway. It does not have to be laser marking, that you can connect all measured data directly with the workpiece by this DMC code and send it to a database. Of course, measuring is a big topic. Here we show one option with an optical system, but it does not have to be optical. We can integrate different systems in here. Also, cleaning the parts is a topic which is very important. So you see there are many, many different options, and this is just a small arrangement of options which can be installed in here. That's why we didn't go to the minimum footprint, that we have the flexibility to work with different additional functions. So far about the concept and the principle of the EMAGLLC. And like always, Johannes will give you some more information how the EMAGLLC can be increased in functionality.
Yes. Okay. Most of our customers ask us if our robot cells has the capability to load them via an HEV system. And our answer with the EMAGLLC is yes. So we decided to have a non-closed safety unit. So we're having a complete open front of the EMAGLLC. But to keep the cell safe, we have to integrate some sensors. Here in the front, we have the laser area scanner with two separate areas. So if the operator enters the yellow area of the scanner, then the robot will reduce its speed. But if the operator enters the red area, then the robot will stop in safe stop. On the inside of the loading area, we have two radar sensors. They detect very small movements, but if the operator or the HEV leaves that area again, then the robot starts automatically again. So we don't need an operator to start after a pallet change. The third safety sensors are our light grid just behind the loading area, and they work as a rear step protection. So we recognize that an operator entered the cell via the front, and then we don't start the robot cell automatically. Therefore, we need an operator to check the cell and start the cell again. With this sensor solution for the HEVs, we are able to handle all different HEV suppliers and also the different HEV systems. So the top loader AGVs are able to enter the cell if we are increase our base in the front, and we are also able to load the front loader AGVs. So here we are independent. So let's talk about how the parts are entering our cell. First scenario is that the parts are orientated and positioned very precise, maybe in blisters. And also they are stacked, and after the robot unloads all the parts out of the blisters by grid, then we have to be able to unload also the empty blister or the intermediate layer. In this case, we are entering a vacuum suction gripper into the cell, and the robot is able to grip these suction gripper, transfer the vacuum, and with this situation we can shift the intermediate layers to another box, or also the blisters. We are also able to store intermediate layers or blisters inside our machine, or like you can see in a small trolley if it's needed. The next scenario is that the parts enter our cell, but we don't know the position of the parts. Here we have two configurations. The configuration 1 is that the camera on the top side of the machine recognizes the part and gives the information of the part to the robot. And with that information, the robot can unload the part out of the pallet. The second configuration is the bulk parts. And here you can see a big box with bulk parts. These parts are very good for recognition because the contour is good, and also the surface is matte. And in the middle picture, you can see how the camera sees the parts. And in that picture, the cameras find all the point clouds in the parts, generates the point clouds of the parts, and then the camera select the part with the highest matching score. This selected part, we find all the position of these parts and also the angles, how the part is in the box, and also the orientation. Further on, the camera decides which gripper position the robot needs for unloading this part. And with all this information combined, the camera makes the path planning for the robot. So the robot can enter the box without a collision and grips the part in a proper way. So with this situation, the robot can unload the box part by part.
Johannes, sorry for interrupting you at this point, because we got an interesting question from the audience regarding the AGV system. We have been talking about this of our safety concept. And the question is, how does communication with the AGV work? Mm-hmm. So the communication between the work cell, I guess, and the AGV system.
Yeah, okay, that's a really good question. All our automation cells have a PLC, and this PLC is the head control of our automation. And this head control talks to the fleet management software. So also we have the interface to the fleet management just for the process signals. So we need the loading signals and the unloading signals, but we don't need the safety interface to the fleet management, because all the safety is done inside our MRC cell. So to round it up, the PLC will talk directly to the fleet manager, and so we are independent of the supplier of the fleet management.
Thank you very much for answering.
You're welcome. Okay, let's continue. Here, now I want to show you some layouts, how we integrate them between our machines. So here you can see the MRC is just between two VT200 machines. The left machine will machining the OP10 and the right one the OP20 of the part. Also, we have inside the cell a cleaning station and a measuring station, and the robot will do the complete handling of the parts inside this cell. Here you can see the basis still an MRC with 4 slots in the front, and the customer loads the parts in small baskets. But here the robot isn't mounted on the base plate of the MRC, but it's mounted on a linear axis. So we have the opportunity to interlink these two SN204 grinding machines. The machines can be loaded through a hatch on the top of the machine. So the robot moves to the machine and load through the hatch and change over the part from the OP10 or OP20 machine. After the part is finished, then the robot will load the cleaning station and the marking station, and after that unloads the part directly back to the basket of the customers. Here you can see an MRC between a CLC 200 and a VL4 machine. In this layout, we are machining gear parts, and I also have a video for that machining. The robot unloads the CLC and loads the part directly on the pallet in the front of the MRC, and the robot loads the raw part to the shuttle of the VL4. And the shuttle is moving to the front of the VL4 to the pickup station, and out of the pickup station the spindle directly loads the part into the working space. Here you can see the cutting of the tooth of at this gear, and here we have another internal automation solution on an EMAG machine. It's a ring loader, which will change over the part from the finished part to the next raw part.
Johannes, okay. Before we continue with the summary,
yes.
We got one more question, I think, regarding the bin picking, if I got this question right. The question is, how high is the degree of emptying? And this sounds like it belongs to the bin picking.
Yes.
Because it's a critical aspect of bin picking. So maybe you can say some words about this.
Yes, I can. So it's a very good question, yeah. We often face this question. It's very hard to give an answer how high the degree is exactly, because we have a lot of influences in this for the degree. The boxes of the customer have a big impact, because maybe the edges of the box are very thick. Then it's possible that the camera don't see the part because there's a shade of the edge of the box, so the camera can't see the parts. The next topic is, if you have a very big box but small parts, then they are laying directly in the corner, so it's also very hard to reach them with the gripper of the robot. So you can see we have a lot of external influences, so we can't say the exactly degree of emptying, but we always offer our customer that they can send us a a filled up box to us at Saarlach, and we do a test how many parts we can emptying out of the box. So please, if you have a exact question to that, then send us a filled up box and we do a test, and together with you we can decide how the emptying decreases can increase. Maybe we can lay angled layers in the bottom of the container of the box, so the parts more roll to the middle of the box, then the degree of emptying is also higher.
Thank you for this very detailed information.
Okay, you're welcome.
And then we can continue in the summary.
Yes, let's continue. Yeah. The EMAGLLC is a very modular concept. We are very flexible in the feeding system, so we can handle baskets, pallets, or even bulk parts. It's easy to interlink several operations to a complete processing line. And we have on the backside space for integration secondary processes, like Jan already told. We can integrate a buffer, cleaning, measuring, or a labeling station.
We're coming to the end of our webinar. And thank you, Johannes, for all your explainings. In the beginning, we have been talking about motivation for automated solutions. We introduced to you the machine-related solutions by EMAG, and we introduced to you our basket handling system, the SCS4, our compact robot cell, and our modular robot cell. As a summary and as a good information for you at the end, we want to hand out some good reasons for EMAG automation solutions to you. At first, you can get all out of one hand. That means not only the machining, also the workpiece handling. Our automation solution perfectly matched to our machines. We are very flexible regarding the feeding systems and concepts, so we can align perfectly to your intralogistics at your production. The EMAG offers a lot of different technologies, which we can interlink from single processing to one complete processing concept. By our machine concept, our machines are all craneable and usage prepared for forklift transportation, so we have very short integration time on site. And last but not least, you can use our fast and well-weight acting EMAG service. This is the end of our webinar. We hope we can give you a good overview about EMAG automation solution. We want to say thank you for your interest and see you next time. Goodbye.
I also want to thank you for your interest and also for the very good question. Have a nice day.